Hi, I am Ranclis Q. Morales from BSEE 3B. So, what is wind turbine? So, wind turbine is a type of renewable energy that harness the power of wind to produce electricity. So, sabi dito, ang wind turbine daw ay isang uri ng renewable energy na ginagamit ang lakas ng hangin upang makagawa ng kuryente. So, the basic idea is that wind turbines uses rotor with attached blades to collect wind potential and kinetic energy. Wind turns the blades, which spins a shaft that is connected to a generator, which result in generation of electricity. A large number of wind turbine is usually called wind farm. So, sabi dito, pinaikot ng hangin ng mga blades na nagpapaikot sa shaft na konektado sa isang generator na nagreresulta ng pagbuo ng kuryente. So, kapag daw marami ang wind turbine sa marami ang wind turbine na magkakasama, so tinatawag daw itong wind farm. So, next. So, makikita nyo dito sa picture ang mga parts ng isang wind turbine. So, yung nasa harap dito is yung rotor, and nakakabit naman dito ang blades, and then low speed shaft, and then gearbox na nakakonekta naman sa generator, tapos high speed shaft. So, sa bandang likod naman ay ang controller, anemometer, at ang wind vane. Tapos yung brake, yaw drive, at yaw motor, at syempre at ang tower. Next is the blade. So, what is blade? So, blade is the part that rotates due to the force it catches from the wind. So, it is connected to the low-speed shaft via hub. Then, the low-speed shaft is connected to the gearbox, and the gearbox to the generator. Once the blade rotates, it causes the rotation of generation, thereby generating electricity. So, ito daw yung umiikot dahil sa puwersa ng hangin. Ito naman ay nakakonekta sa low speed shaft sa pamamagitan ng hub. Kapag umiikot ng blades, ito ang nagpapaikot sa generator upang bumuo ng kuryente. So, most wind turbine consists of 3 blades for maximum efficiency. So, next is the blade design. So, blade design. To produce an amount of power, wind turbine blades generally need to be large and tall. It is shaped to generate the maximum power from the wind at the minimum cost. Improvements in the design has produced new wind turbine which are more compact, quieter, and generates more power from less wind. So, sabi naman dito, para daw makagawa ng power, ang mga wind turbine blades daw ay kailangang malaki at mahaba. So, sinadyang ganito ang disenyo ng blades para makakuha ng pinakamalakas na power mula sa pinakamababang halaga. So, its length vary at around 50 meters with 107 meter currently the longest from Siemens Gamesa. So, ito daw yung pinakamalaking wind turbine na nagawa ni Siemens Gamesa. So, next is the airfoils. So, airfoils is the cross-sectional shape of the blades that determines its aerodynamics. So, they are the key to blade design. This airfoil design allows the blade tips of a wind turbine to move faster than the wind, thus generating more power and higher efficiencies. So, ang mga ito daw ay susi sa sa design ng blades. Ang disenyo ng airfoil na ito ay nag-aalaw sa mga dulo ng blades na gumalaw ng mas mabilis kaysa sa paggalaw ng hangin. So, nagdudulot ito ng mas malakas at mas mabilis na pag-ikot. So, ito naman yung iba't ibang design ng blades airfoil. Iba-iba din kasi yung mga design nito, depende kung ano yung requirement sa isang power plant. So, next is the blade aerodynamics. So, blade aerodynamics. Wind turbine blades work by generating two aerodynamic forces, lift and drag. This is due to wind and their airfoils. Lift force is perpendicular to the airflow and is in line with blade rotation. Drag force is in line with apparent wind direction, which is in opposition of the blade motion. Drag increases in proportion to the frontal area of an object facing the wind. So, ang wind turbine blades daw ay gumagana sa pamamagitan ng dalawang aerodynamic forces na ang pag-lift at pag-drag. So, ito daw ay dahil sa hangin at sa airfoil. So, sabi dito, ang puwersa daw ng pag-drag ay naayon sa direksyon ng hangin na sumasalungat sa galaw ng talim ng blade. Blade. Sumasalungat sa galaw ng blade. So, ang pag-drag ay tumataas sa proportion sa frontal area ng isang bagay na nakaharap sa hangin. So, another thing that the airfoil is able to bring is for the blade to attain difference in pressure on both sides. So, the most curved side, or we may say the convex side, generates low air pressure, while high pressure air pushes on the less curved side, or we may say the side with slightly concave part. This is actually the reason for blade rotation. So, ang nakakurbang bahagi daw ay bumubuo ng mababang pressure ng hangin, habang ang mataas na pressure ng hangin ay tumutulak sa less curved na bahagi. So, ito ang dahilan ng pag-ikot ng blades. So, here is now the question. Based on the figure illustrating the optimum angle of attack, which part of the blade is the leading edge and trailing edge, front and back? So, yung edge na nakaharap sa hangin is yun yung mas curve. And yun yung leading edge. And yung mas point na nakikita nyo ay yun naman ang trailing edge. So, ito naman yung formula how to lift and drag force are being computed. So, nakikita nyo sa bandang itaas is yung formula ng lift force. And then sa bandang ibaba naman is nandun naman yung formula ng pagkuha ng drag force.
So, good day everyone. I am Jinmiko M. Quitan from BSEE 3B. So, I'm your next reporter. So, umpisa natin. So, wind turbine aerodynamics. Excuse me. So, blade rotation. So, what will be the rotation of the blade? So, paano nga ba nag-rotate yung blade? So, saan nga ba dapat natin siya itulak or ano ba dapat natin gawin or alamin para alam natin kung saan ba to patungo or saan ba natin to gagalawin. So kailangan mong i-push yung blade sa less drag. So less carbs. So which is for example nandito yung turbine natin and meron siyang dito sa picture na to, ayun makikita natin dito na kapag yung wind turbine is less drag sa side na to, so kailangan mo siyang itulak pataas. So, masasagot natin yung tanong na to kapag alam natin yung sequence ng pag-ikot ng blade. So, kasi the most important thing is kailangan mo munang inspect yung blade kung saan ba siya less carb dahil hindi pa laging pataas or pababa yung pagtulak ng blade. Lagi mo itong titingnan or i-inspect kung saan mo ba siya dapat itulak doon sa may less carb. Next, so, ito lang din yung sinabi natin kanina. So, basahin lang natin. Blade, wind orientation. All current day wind turbine blades rotate in clockwise direction as seen from an upstream perspective. The choice of the rotational direction impacts the weight if the wind profile changes direction with height. Next, wind turbine parts and design. So, blade design. So, blades are the oldest blade design and have been used for thousands of years on windmills. So, but this flat, broad shape is becoming less common than other types of blades design. The flat blades push against the wind and the wind pushes against the blades. Curved blades are very similar to a long airplane wing, also known as airfoil, so which has a curved surface on top. The curved blade has air flowing around it with the air moving over the curved top of the blade faster than it does under the flat side of the blade, which makes a lower pressure area on top and therefore, as a result, is subjected to aerodynamic lifting forces which create movement. Excuse me. So, makikita natin dito sa picture na to. So, di ba ayun, no? Pa-curve siya, pa-twist siya, and pa-tapered. So, twister and tapered blades enhance its aerodynamics. So, ano nga ba yung maidadagdag ng twisted and tapered blades? So, these lifting forces are always perpendicular to the curved blade's upper surface, which causes the blade to move rotating around the central hub. The faster the winds blow, the more lift that is produced on the blade. Hence, the faster rotation. So, sinasabi dito na mas nakakatulong yung twisted and tapered blade dahil sa faster the winds and the more na mabilis yung wind is more lift that is produced on the blade. Hence, mas mabilis daw yung pag-rotate ng blade. Faster the rotation of the blade. Next. So, What number of the blades is the best design in consideration of all factors in construction and operation of wind turbine? So, 1 blade, 2 blade, 3 blade, or more. So, alamin natin kung, so ang sagot lang dito is 3 blades. So, alamin natin kung bakit nga ba hindi naging 1 and 2. So, next is yung rules ng, natin. The rules of thumb are, so, the fewer the blades, the better, since there will be less drag and increase in efficiency. So, di ba sinabi ko kanina, kung saan less drag, dun mo siya itutulak para mag-rotate yung blade. So, sabi lang dito na kapag mas kaunti yung blade, mas okay, less drag. Yun lang yung rules na pinapaliwanag dito sa rule 1. Next is the number of the blades increases the torque and reduces the optimum rotation speed. So, kapag daw madami yung blades, pag daw dumadami yung blades natin, nagiging malakas siya, pero yung pag-rotate niya is bumabagal. So, yun lang yung ibig sabihin nito na kapag madami yung blade, mas mabagal yung pag-ikot ng blade. Okay? So, bakit nga ba hindi pwedeng maging 1 blade? So, sabi dito, because of the decreased drag, 1 blade would be the optimum number when it comes to energy yield. So, meron din itong side effect na, however, sabi kasi dito, however, 1 blade could cause the turbine to become unbalanced. So, magiging unbalanced daw yung turbine natin kapag 1 blade lang yung ginamit natin. So, hindi siya magiging stable for turbine. So, and this is not a practical choice for the stability of turbine. So, hindi pwedeng maging 1 blade kasi nga hindi siya stable. Magiging unbalanced siya. Next is 2 blade. 2 blade is a technically on a par with the established 3-bladed design. So, for the benefit of a potential simpler and more efficient rotor structure with more option for rotor and nacelle erection, either higher cyclic loading must be accepted or the complexity of a teeter hinge introduced. So, the teeter hinge allows the 2 blades of the rotor to move as a single beam through positive negative 7 degree in an out-of-plane rotation. Allowing this small motion can much relieve loads in the wind turbine system, although some critical loads return when the teeter motion reaches its end limit. The 2-bladed rotor is a little less efficient aerodynamically than a 3-bladed rotor. So, hindi din naging balance yung 2-blade natin, dahil sabi dito, the 2-blade rotor is a little less efficient aerodynamically than a 3-bladed rotor. And hindi talaga siya maging balance kasi pagiging yung isa, dapat yung isa kasi nakatutok sa may padiretsyong gano'n, and then yung dalawa nakatutok sa may angle. Okay? So, kaya hindi siya naging perfect hindi naging perfect yung 2-blade natin para sa wind turbine. Next, more than 3 blades. So, more than 3 blades. Any number of blades greater than 3 would create greater wind resistance, but slowing the generation of electricity and thus becoming less efficient than a 3-blade turbine. So, kapag naman sumobra sa 3 blade na, so sinasabi dito na greater than 3 would create greater wind resistance. So, nakaka-create daw ng greater wind resistance. Pero, yung pag-generate ng electricity is bumabagal. And, thus, becoming less efficient than a 3-blade turbine. So, next is 3-blade. So, bakit nga ba naging 3-blade yung pinaka sakto sa wind turbine natin? So, dahil kay sa 3-blade, nagiging maayos yung pag-ikot nito. Dahil nga, sabi dito, this is because their angular momentum in the vertical axis changes depending on whether the blades are vertical or horizontal. With 3 blades, the angular momentum stay constant because when one blade is up, the other 2 are pointing at the angle. So, sinabi dito, kapag yung isa daw is nakaturo sa taas, yung dalawa naman daw ay nakaturo sa may pointing at an angle. Nakaturo naman sa angle. So, Nang dahil doon, yung wind turbine natin is can rotate into the wind smoothly. So, nakaka-rotate siya ng maayos and maginhawa. So, sana naintindihan nyo kung ano yung naging report ko, and ang next reporter natin is si Bong Mercado.
Hello everyone, my name is Bong Christopher El Mercado from BSEE 3B. So I am your next reporter for today. Wind turbine. Um, Wind turbine. Parts and function. So blade tilting mechanism. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor coupled parts of the wind turbine which tilts the blades and guarantees a proper alignment of the blades with the relative velocity so that its position is always at the optimum angle of attack. So dito daw sa ayon daw sa bilis ng hangin ay nagbabago din daw yung velocity angle of the wind. So ang blade tilting mechanism daw ay nagsisensor ng wind para daw ma-align niya yung mga blades kung saan yung tamang alignment para tama din yung pag pag-ikot. So next, nacelle. The housing at the back of the blade which contains the slow speed shaft, gearbox, generator, and other small parts inside it. So, ang nacelle daw ay ito, yung nasa yung housing daw sa back na nagko-contains nga ng ayan. Next is gearbox. The component which converts the slow rotation of the slow speed shaft into faster speed. This is needed simply because the rotation of the slow speed shaft is usually not enough for a generator to achieve a grid quality voltage output. Most generators need to be turned at 15 RPM for 50 Hz and 18 RPM for 60 Hz. In no way it is feasible for a turbine blade to move that fast. So yung gearbox daw ay nag-convert ng slow rotation pero nag-speed ay nagtuturn ito sa speed. So parang etong gearbox ay kahit mabagal yung ikot ng blade, mabilis yung pag-achieve ng quality voltage. So, pag daw 15 RPM ang need daw nito ay 50 Hz, ang 18 naman 60 Hz. So, ayan. Ito pa yung function ng gearbox. So, a common ratio is about 90.1 with a rate 16.7 RPM. Input from the rotor to 15 RPM. Output for the generator. Next is direct drive, gearless. In direct drive turbine, there is no gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to gear type, the slow rotation and decrease in moving parts of PMDD generator reduces fatigue and stresses on the turbine, resulting reduced noise and vibration, longer lifetime and lower cost of maintenance. So, yung direct drive daw, yung gearless, wala daw siyang gearbox. So, yung turbine daw ay nag-i-spin sa mismong generator. So, dito ang Ang kaibahan ng sa gear type, the slow rotation and decrease in moving parts of PMDC generator. So, kung kung ano yung bilis ng natatanggap ng turbine and din yung papasok sa generator. So, hindi siya katulad nung may gearbox. So, ang advantage naman nito ay less maintenance and parang hindi hindi madaling masira pag gearless. So, other function is an important fact is that due to wind inconsistency, the gear type turbines often operate at partial loads. The efficiency of the PMDD generator excels even these conditions because it continues working nearly to nominal values. This design to make suited even in offshore wind application. So, next is one main disadvantage of PMDD is that make up for its slow rotation. More magnets are added to create the required frequency and power. This increases the diameter of the generator, which makes it larger and often heavier than geared type wind turbine. Another thing is that the additional magnets being used is in this type is made of neodymium, neodymium, which is expensive. So ang disadvantage daw nito ay gawa daw to sa mas maraming magnet dahil mas kailangan nitong um, mag mag-supply ng power and frequency. So dahil dito sa magnet na to, mas lalong mas lumaki yung na to tapos mas mabigat. So kaya ang gamit pa lang magnet dito ay neodymium. So which is expensive. Next is the cost and weight of the direct drive turbines have prevented it from presenting major competition to the gearbox turbine until recently. But other experts claim that direct drive technology will eventually become a dominant one, since the gearbox wind turbine is almost at its maximum efficiency point, while the PMDD generator have more possibilities for improvement. So, nakikita naman daw dito ng mga experts na mas lalong i-improve yung pag-collect ng energy dito kumpara sa may gearbox type. So next is brake. The brake system is a wind turbine is a protective device coupled with the sensor which automatically stop the rotation of the blades whenever it detects activities that could harm the system during operation. Very high wind speed, vital parts not working, maintenance in power lines, and etc. So, yung brake daw ay nag-sensor daw to ng kapag merong um, masamang mangyayari sa mga tools, ayan, mag mag-automatically na mag-i-stop yung rotation ng blade. Ayan. Next is yaw system. Yaw system is a sensor-equipped mechanisms consisting primarily of yaw motor, yaw drives, and others. Its function is to automatically rotates the nacelle on the top of the tower so that the sets of the blades is facing the wind directly at the times. It detects its proper direction through the electronic information being fed by the wind vane located at the back. This ensures that wind turbine is producing the maximum amount of electricity energy. So, yung yaw system daw ay nagsisensor daw to ng um, to? Nagsisensor ng wind. Yung yaw system ay um, siya yung directly na nag-face ng wind. So, dahil siya yung nag-face ng wind, um, siya din yung nagde-detect kung saan haharap yung blades natin. So, yun lang po't maraming salamat.
Good day everyone, my name is Rubio from BSEE 3B and I am here to discuss the continuation of the wind turbine parts and function. Let's discuss first the tower. Yung tower is yung pinagkakabitan ng blades ng wind turbine. Wind velocity increases at higher altitude. This means the taller the tower, the greater electricity it can produce. Kung gaano kataas yung tower, mas mataas yung mapoproduce niya na electricity. Kung mababa naman yung tower, low electricity din naman yung mapoprovide niya. Next naman is majority of wind turbines are supported by conical tubular steel towers with a height of usually 75 to 110 meters or 250 to 370 feet. It depending on the blade's diameter. Dito naman, kung gaano kalaki yung tower is nakadepende kung gaano kalaki or yung diameter ng blades. The tallest is still for completion in the mid of 2022, which is 280 meter to be installed at the test center in Western Julian, Denmark. Dito naman is sa tower, dito nasusukat kung gaano kalaki yung maipoproduce na electricity kasi the higher the tower, the higher or the greater the electricity can provide. Kung maliit yung tower mo, it means na mas maliit din or less electricity yung mapoprovide niya. Next naman, let's discuss the ideal location ng wind turbine. The ideal location of wind turbine is coastal area. The best places for wind farm are in coastal areas, at the tops of rounded hills, open plains, and gaps in mountains. Places where the wind is strong and reliable, some are offshore. Dito naman kung paano natin malalaman kung saan yung best place ng pagtatayo ng wind turbine is kung saan mas mahangin. Kasi mas mahangin, mas greater electricity yung mapoprovide niya. To be worthwhile, there should be an average wind speed of around 25 km per hour. Dapat merong 25 km per hour yung mapoproduce na hangin dun sa may pagtatayuan mo ng wind farm. Next naman is let's discuss the wind turbine advantage and disadvantage. First, for the advantage, wind is free. Wind farms need no fuel. Dito naman yung wind is free, yung mahangin siya, tapos hindi na kailangan gamitan ng mga fuel. Next naman is produces no waste or greenhouse gases. Next, the land beneath can usually still be used for farming. Dapat yung land or yung pagtatayuan natin is nagagamit siya for farming. Next naman is for the last one, for the advantage is a good method of supplying energy to remote areas. Dito naman is good method means dapat maganda yung masusupply niyang energy para sa area na gagamitin yung wind turbine na yon to produce the electricity. Let's go for disadvantage naman. Disadvantage first, the wind is unpredictable. It changes speed throughout the day and from season to season. Dito yung unpredictable yung wind, yung hindi natin masasabi na yun, nakapirme lang or same lang lagi yung wind na dumadaan dun sa area na yon. Dapat nag-change yung speed nung wind dun sa area na yon. So, yun yung disadvantage nun. Next naman is suitable areas for wind farms are often near the coastal area where land is expensive. Expensive means magastos. Next naman is can affect television reception or nearby places. Nakakaapekto yung wind farm dun sa may places or sa lugar na mas malapit doon. Tapos yung mga television siguro nawawala ng signal yung television nila pag high electricity yung napoproduce nito or how low electricity. Next, let's summarize the parts of the wind turbine. The pitch, the rotor, the blades, the brake, the yaw system with the yaw drive and yaw motor, tower, high-speed shaft, low-speed shaft, gearbox, generator, anemometer, controller, wind vane. The anemometers measure it's direct the south, east, west, ganon. Tapos naman yung wind vane is yung sukat nung hangin.
My name is John Michael Nolian from BSCE 3D for EE elective. And I'm here to discuss about hydrogen power plant. A hydrogen power plant and its working principle is a also design for a widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electricity. So, yeah, makakuha siya ng electricity. So, makita natin sa mga picture, example nun, mga yun, mga hydrogen power plant. Here, ito yung sa CNM energy na mati-discuss later. The language. Naman, so hydrogen fuel cell parts and design. So, okay, sa una, okay, ito tapos ba ito? Hindi na tapos. Manual. So, sa una, makikita natin dito, yung hydrogen at ang oxygen, susupply itong yung anode and cathode ng hydrogen and oxygen. Makikita natin na yung hydrogen na nag-react sa catalyst. Tapos, the hydrogen molecule na-split sa two na protons and electrons, makikita natin sa taas. Padahal sa taas yung electrons, tapos yung protons sa baba, ayun. Tapos these two heads, so punta sila sa cathode part, sa catalyst ito. Wait, ayun. Yun. Note that the PEM or proton exchange membrane only allows proton to pass through. May tinam natin dito, sinabi ko kanina na makakapasa lang dito yung protons or sa taas ng electrons sa wire. What happens next is those two particles pass through. Earlier, pass through. Yes, with the help of catalyst, which is made of platinum, by the way. I forgot to say earlier dito sa kabilang side. Which creates byproduct na air, water vapor. So, yun. One, mapasok yung hydrogen. Pangalawa, oxygen. Pangatlo, babalik dito yung hindi ko nasabi kanina, babalik. Pangapat, yung hatian by catalyst na platinum. Dito mapunta yung electron. Dito naman sa papass through naman sa PEM o proton exchange membrane yung protons which na makukuha ng oxygen yung dalawa na particles then goes out as air and vapor. Air and water vapor. Yes. So next. Battery parts and functions. Electrolyte is the medium that provides the transport mechanism between the cathode and anode of a cell, ammonium, chloride, zinc, chloride, potassium hydroxide, lithium, tin, phosphorus, sulfide, and sulfuric acid. The anode, the terminal or electrode from which electrons leave a system in a battery or source or other source of the direct current, the anode is the negative terminal, negative anode. But in a passive load, it is a positive terminal, passive load, right? Which is made by zinc, lithium, metallic lithium, at lead. The cathode is the metallic electrode through which current flows out of polarized electrical device. Conversely, an anode is the electrode in a polarized electrical device through which current flows from an outside circuit. So, so hydrogen fuel cell. So ito basically yung kanina, ito. Hydrogen fuel cell parts. So paano sila gumagana. So hindi ko na siya pabasahin, which is kind of long. So hydrogen fuel cell. Bakit? It has several benefits. Benefits over conventional combustion based technologies currently used in many power plants and passenger vehicles. Which means hydrogen is efficient as a fuel source capable of producing many energy per pound of fuel than gasoline. This means an equal size weight tank of hydrogen fuel will give a vehicle a greater range or more power than when being filled by gasoline. So, in-explain ito na mas malaki na binibigay na itong hydrogen fuel cell at binibigyan ng more or greater range or more power than when being filled by gasoline. So again, one fuel cells have lower emissions as explained kanina, maging water vapor. There are no carbon dioxide emissions, so yes, it's quiet. Yeah, hindi na gagamit ba nung what can I say? Ang klaseng let's say basta yung makina na kumakain ng fossil fuel and whatever. Kasi maingay yung makina na yun. Okay, next. So, hydrogen power plant. I forgot kanina. Ito yung example kayo ng hydrogen power plant. Where am I? Ito yung sasabi ko nila nawawala, yung long range. Sorry. So, ito naman, kanina, We can see here sa yung parang sa fuel cells lang yung hydrogen papasok dito sa anode and cathode. I mean, the hydrogen and oxygen papasok sa anode and cathode sa kabila sa cathode to. Ito naman sa anode. And same process lang din. Here we can see yung water vapor. Pero dito naman kailangan din ng DC to AC inverter kasi itong process na to will make a DC current na kailangan natin palitan to AC para magamit, which leads to grid transformer o substation. Ito sa local grid. Okay, next. Basically, this whole process na-explain na kanina. Close that. So, latest updates on hydrogen power plants. So, Siemens Energy at 170 million euro facility in French Guiana. This facility can provide up to 10 megawatts of power during day and 3 megawatts during night. A renewable world's largest hydrogen power plant with a 16 megawatt machine for electrolysis of water. Excuse me. 3 megawatt fuel cell. 55 megawatt solar panels. That's huge. 55 and 20 megawatt to 38 megawatt per hour of batteries has begun construction as of 2021 in a French Guiana, whatever. Long range energy generation project. A 485 megawatt facility built in United States, Ohio, by the way. It is a facility equipped to run a mix of natural gas and carbon-free hydrogen. It is nearing to its completion at the site of a former aluminum smelter at the banks of Ohio River. The facility first will burn the fuel in the blend that includes 5% hydrogen and the General Electric plus turbine. The plant is intended to transition to 100% hydrogen over the next decade. So this thing will become large by the next decade. So bakit daw yung this thing earlier ay hindi pa na mainstream na like overused na ngayon? Hydrogen production through methane, 90% of the hydrogen used today is produced by steam reforming, separating hydrogen atoms from carbon atoms in methane, too long or directly. This process is expensive. TLDR or summary, this process is expensive and it is greenhouse gas which contribute to the global warming. And hydrogen production method in which electrolysis, which separates water and production separate through water the production test hydrogen from water. So basically, in summary, it's expensive and it doesn't return pretty fast. And why hasn't it gone mainstream? Again, the reasons: hydrogen storage. There's a problem in a way in the storing hydrogen because of its low density. Means we need the strong tanks and heavy duty refueling lines, as there is no yet logistics in this type of storage yet. Means this is it's a practical disadvantage. So yeah, hydrogen leak. A leak can occur in June 2003. Hydrogen leak from widespread use of hydrogen fuel may or would gobble up ozone faster than CFS, chlorofluorocarbons too. Basically, by last slide 10 to now, in summary, it's expensive and we lack the technology to harness it to its full extent for now. I guess that's it.
Let's summarize the hydrogen power plant. A hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. Hydrogen power plant is ito yung bagong design para mag-produce ng electricity gamit ang hydrogen. Large tank of liquid hydrogen will feed into thousands of hydrogen fuel cells. Dito, yung liquid hydrogen, pag madami kang liquid hydrogen, doon na-fill yung hydrogen fuel cells. These fuel cells are solid structure containing an electrolyte fluid and two terminals much like batteries. Ito yung kamukha ng batteries. Merong anode and cathode. Then, nagpo-produce siya ng electricity. Next is Next naman, discuss na lang natin yung latest development. Ito yung longest hydrogen power plant, the Long Range Energy Generation Project. It has 485 megawatts. Facilities being equipped to run on a mix of natural gas and carbon-free hydrogen. The facility is located at the banks of the Ohio River. The plant is intended to a transition to 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machine that splits water into its hydrogen and oxygen elements. The company that has hydrogen power plant is Siemens Energy. Construction begins on world's largest green hydrogen plant, part of unique base load solar project. And that's all our report for the wind turbine and hydrogen power plant.